This is a video about voltage dividers, what they are, how they're built, what they're used for, how they work. And what I have here on the Digital and Electronics Explorer board are three potentiometers set up in series. I'm feeding power from my power rails at 6 volts into the first potentiometer. It flows into the second potentiometer, into the third potentiometer, and then off to ground. So there are voltage drops across each of these potentiometers when they're turned up to have resistance. And therefore we have different points within the circuit with different voltage levels. Those voltage levels are then tapped off here and sent to the various scope channels. Scope channel 1 has the voltage at the entrance to pot 1. Scope channel 2, the entrance to pot 2. Scope channel 3, the entrance to pot 3. And then we're using channel 4 to just display the ground level, which is the output of the third pot. That's just to show it on the oscilloscope, which is what we see right here. We have 6 volts in yellow at the start of the first pot, and then at the entrance to the second pot it's 4 volts, entrance to the third pot 2 volts, and then down to ground at the exit to that last potentiometer. What we're also showing here on the Fluke meter is the current flow across the entire system. We're just measuring that over here, feeding that into the Fluke meter. By simple symmetry, we can see that there's a 2-volt drop across each of those three potentiometers. And by that symmetry, we should know that the resistance of each of these is the same. So we're going to take a look at that by using our BK precision meter. And I've set up a point here on the breadboard where we can just put those pots in place and look at the resistance across each one of them in turn. So I'll look at the first one by moving that over here. It's got a resistance of, it says 352 ohms. Move the next one in place. 373 ohms. And then the third one. 363 ohms. So within maybe 10 or so ohms of the middle value, they're all about the same. So yeah, the scope values are just estimated, and we come close to symmetry there on the values of the resistors being the same. So what we're looking at here, and I wanted to just modify the resistance of these and have a look at what happens to the current as well as the voltage. Once again, we have 6-volt total voltage drop across all three of these. So what I'm going to do is I'm going to turn down the resistance of the first potentiometer to 0. So basically, I'm going to turn that into a short. The thing to notice, and I'll do it again, we see a rise in the current because I'm reducing the overall resistance of this simple circuit by dropping the resistance of this first pot. And we also see that the voltage drop across that first one, which is represented by this gap, goes to 0 because it becomes basically a short, turning it down to 0. And now we still maintain the symmetry. We have a 3-volt drop across the second potentiometer, 3-volt drop across the third potentiometer, because we still have to maintain that 6-volt drop across the entire system. Turn that back up again, and we'll do the same thing with the second pot. Once again, we can watch the current, and we can watch the voltage changes across those. So there we go. This is the voltage drop across the first pot. The voltage drop across the second is 0 because it's shorted, and so this represents the voltage drop across that third one of 3 volts lost here, 3 volts lost here, and then a shorted pot right there, which I just turned down to 0. Now, the usage of these voltage dividers is to basically use one power supply to supply different voltages to different parts of your overall system. So maybe sub-circuits that require different voltage levels. We're going to simulate that with these LEDs over here. I've got some resistors in place to limit the current through these LEDs, and when I connect these subsections of the circuitry will actually be connected and in place, and you'll see the LEDs light up. There's a yellow one, putting a blue one in place. The blue one lights up, and now a red LED, and it lights up. So let me shut off this light so you can see that a little bit better. You may have noticed that the current also went up, and that's because now we are adding sub-circuitry to this overall system so that the voltage provided to each of these LEDs is inferring that there's current flow, or forcing current flow through those LEDs and lighting them up. If I were to turn down that third resistor to 0, so it shorts, it would be shorted to ground, and that would mean that the input voltage to this red LED would be 0. So I'll do that. Turn that down to 0. And you can see that that LED went out. Rising up again as I change this. As it gets to about 2 volts, that LED lights up, because a red LED requires roughly 2 volts for it to light. So this is just a simple demonstration of voltage dividers. Hopefully provided some useful information and insight. That's it for this video. I thank you for watching.